To all. Today we'll discuss Yates correction with an example. So we have a formula to calculate Yates correction is 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 equal to observed frequency minus expected frequency bracket, and that bracket is covered by a modulator, and minus 0.5. So we'll make a whole square for this, and this is divided by E. So this is our formula. So what we have to calculate is, first we look into the observed frequency, followed by we need to formulate expected frequency, and in that we have to minus observed frequency minus this expected frequency, followed by again we have to minus with this zero point 0.5, and followed by we have to do this whole square same, and followed by we have to divide this E, and the last we have to do that is summation. It means nothing but adding of those all observations, calculated observations, and that is nothing but our Yates correction final chi-square answer. So another formula, if we were having 2 into 2 contingency table, we can do by this formula also, that is chi-square is equal to n bracket a AD, actually AD, and this is a modulation, minus BC, so which is again subtracted by n by 2, and this is whole square by 2, so which is divided by A plus B. So same yesterday we discussed in the formula, B plus T, C plus T, and A plus C. So this formula is only applicable when the contingency table is 2:2, and when we have to use this Yates correction means, so in contingency table means when we have to use this Yates correction means when the contingency table of any cell frequency, any cell's frequency which is less than 5 means, then we have to use this Yates correction formula, to calculate chi-square. So yesterday means in the last class what problem we discussed, that is actually chi-square test. But in the contingency table, if the any cell which contains less than 5, then that we can't use that chi-square formula, we need to use this Yates correction. So we'll discuss an example which is having 2 into 3 contingency table. Yesterday we discussed 2 into 2 contingency table. Today we are going to discuss about 2 into 3 contingency table, means there were 2 columns and 3 rows will be there. So the contingency table will be age group of under 25 to 45 and over 45. So next is feature of A, and next one is feature of B. So actually this is the question, content of the questions, not exactly questions. Sometimes they will give exactly the similar question like this already formed table, or else sometimes they will give for example, a researcher wants to investigate if there is a relationship between persons of age group and their preferences of a mobile app feature or anything. So feature A is a survey of 30 peoples of collecting following observed frequencies at the level of 0.05, and we need to find the association, and we need to calculate the table value, not exactly means at the point of alpha significance is 0.05. We need to check the chi-square value at table value of 0.05, and this is commonest one, means maximally they will give at 0.05 level of table value. So this is the question. then we have to make it total, adding and all. So total will write here. For this total, place is not there, but total. So next we have to add these all. What will get, we have to write down here, which is nothing but 19, and we have to add this, we'll get around 11, and we have to add these 12. So this is 12 and this is 15, and we have to add this one and this one. This is going to be 3. So what we have to do is we have to add completely, we'll get 30, or else we have to add these two, we'll get 30 itself. So this is our total, which is nothing but our n, total number of observations, that is n. So next, according to formula, we'll move. So this is our observed frequencies. So what we have, in each cell we have to write what all contents we have. Firstly we have 10, then it's going to be 2, 8, 7, the table values I am taking here, followed by 1 and 2. So what we need to form next means we need to find out the expected frequency. So yesterday what we did, same, how to calculate expected frequency here means expected frequency of cell 10 is equal to, cell 10 belongs to the corresponding value is 19 here, and this corresponding value is 12 here. So what we have to do is 12 into 19 divided by total number of observations we have, that is 30. So we have to calculate here. So what value will get? Will get around 7.6. So this is our expected frequency, that is 7.6. So next, for cell 2 also we have to do the same, and we'll get around see, this is a cell 2 means cell 2 means this is 2's corresponding one is 12 and this corresponding is 11. So 11 into 12, 11 into 12 divided by 30. So what we'll get? We'll get around 4.4. So we have to mention it here, 4.4. Similarly for all we have to do, we'll get around, this one is going to be 9.5, and this one is going to be 5.5, this one is 1.9, and this one is 1.1. So next what we have to do? We have to do is observed frequency minus expected frequency. So we have to minus. So 10 minus 7.26 means we'll get around 2.4. Similarly 2 minus 4.4 means we'll get the value in a minus, and that is 2.4. And similarly like this 8 minus, and this will get as positive, and this is going to be minus 0.9, and this 1 into minus 1.1 means it's going to be 0.9 again. So what we have to do, the next step is we have to do a modulation. Means the modulation is for the purpose whatever answer will be there will convert into positive, means the outcome will be in the form of positive. Again in that modulation what we have to do, we have to do the minus 0.5. So modulation means this is positive and already positive. 2.4 minus 0.5 means we'll get around 1.9. Similarly minus 2.4 means which is nothing but positive again. After putting in the modulation we'll get this value as positive. So 2.4 minus 0.5 means we'll get around 1.9. Similarly 1.5 minus 0.5 means after putting in the modulation we'll get this, will remove this negative signs, we'll get 1. Similarly 1, and this is going to be 0.4. After removing negative, after putting modulation the negative sign will go, and minus 0.5 will get 0.9. Similarly 0.4. So what is our next step here is we have to do that observed frequency minus expected frequency, modulation minus 0.5, this square we have to do. So 0.9 into 0.9 will get around 3.6. Similarly we have to do 1 for 1 only, this is 0.16 and 0.16. So in the formula we have to check, this is the formula. So in this formula we did till that. Next we have to do divided by expected frequency. So here I am doing the same thing. So observed frequency minus expected frequency modulation minus 0.5 whole square divided by E. So what value we have got, we have to divide this by this. So what we'll get, we have to keep this as it is. So this is after dividing and all, we'll get 0.4, this will be 0.81, and this is 0.1, this is 0.81 again, and this is going to be 0.08, and this is going to be 0.14. So what is our next step here means we have to calculate this, means we have to add these all value summation of chi-square, so which is nothing but we'll get around the value of 1.715 something. So we have got chi-square of 1.715. So next what we have to do is we have to calculate degree of freedom. Yesterday we discussed that calculating the degree of freedom is number of rows minus 1, number of columns minus 1. So similarly column minus 1 and into row minus 1. So column, we have two columns, sorry we have three, sorry in this formula we have to check this. So we have two columns and we have three rows. So what we have to do, 2 minus 1 and 3 minus 1. So this is going to be 1 and this is going to be 2. So 2 into 1 is 2. So degree of freedom is 2. So what we have to do here is at the level of alpha significance 0.05 and degree of freedom at 2, what the table value will get, we have to mention it, and the table value will be 5.991. We need to know that how to check a table value first. I'll explain how to check table value also. So this is after checking the table value, we'll get the value chi-square table value is 5.9111. So this is more than that the chi-square value. So yesterday, so what did I say? So when the calculated value is less than the table value, then H0 is going to be accepted. If the table value is less or calculated value is more, then that H0 is rejected and alternative hypotheses were formed. So before starting this formula, we need to formulate that H0 means null hypothesis. We didn't frame the null hypothesis. So here the null hypothesis is accepted. So I'll write the inference. So is this clear? Okay. Table value, or we used to call it as critical value also. Table value or critical value. Critical value. So at the level of 0.05 value or critical value at the level of 0.05 level, significance, level of significance, that is alpha. So and 2 degree of freedom of 2, and the table value is 5.991. So what we have calculated, to know that calculated chi-square value is 1.715, and which is less than the table value or critical value. So our H0, which is nothing but null hypothesis, is going to be accepted. So we have to frame null hypothesis. H0 is accepted. There is no significant association between age group and preference for mobile features, or commonly you can call it as features A and B. So like this we have to do. So here we discussed chi-square as well, its correction. So we need to know that when we have to do chi-square and when we have to do the its correction. Thank you.